So, in the world of AI, the big idea for years has been bigger is better, right? We've all seen these models with billions, even trillions of parameters. But what if that's the wrong way to look at it? Today, we're diving into a paper that throws a huge wrench in that idea. It's about a tiny AI that's built to think more like a brain. And honestly, it challenges everything we thought we knew about building intelligent machines. Okay, let's get into it. And we're going to start with a real head scratcher. We have these gigantic AI models. They can write poetry, they can write code, but they just completely fall on their face when you give them a problem that requires deep, step-by-step reasoning. So why? Why can these massive models not solve puzzles that, a person could just sit down and figure out? It's a real mystery in the field. And I mean, just look at this table. The results are staggering. On one side, you have this new thing, the hierarchical reasoning model, or HRM. It's got a tiny 27 million parameters, but look at it go. It's crushing these super hard reasoning puzzles. And on the other side, the biggest, baddest large language models out there. Thousands of times bigger. And their score? A big fat 0. Not 1%. A complete and total failure. So this brings us to the big question, right? How on earth is this possible? It just doesn't feel right. It's like watching a souped-up go-kart just lap a Formula One car in a race. You just know something fundamentally different has to be going on under the hood. The paper just nails the problem with this one quote. See, when the authors say that LLMs are shallow, they're not talking about the number of layers. Nope. They mean their computational depth is shallow. Every time information passes through the network, there's a hard limit on how much thinking it can do. And that's what's holding it back from real, deep, multi-step reasoning. So how have people tried to get around this problem? Well, the main trick is something called chain of thought. It's pretty much the go-to method today. You basically just prompt the model to, think out loud, to show its work by writing out all the steps it's taking to get to an answer. But the paper argues that chain of thought is really just a temporary fix. They call it a brittle crutch. First, it's brittle. If the model makes one tiny little mistake in step 1, the whole logical process can just completely collapse. Second, it's super inefficient. Generating all that text just to think takes a lot of time and a ton of power. And finally, it chains the AI's reasoning to language. But think about it. Do you really think in full sentences when you're solving a puzzle? Or is it something more abstract? Real thought probably happens somewhere deeper. Okay, so if the current approach is hitting a wall, where do we look for a better one? Well, the researchers turned to the only working model of general intelligence we've ever found, the human brain. They decided to build a whole new AI architecture based on how it works. And one of the most basic principles of your brain is that it operates on different speeds. You've got these high-level areas that do the slow, careful, big picture planning. And then you have all these other circuits that are just zipping along, executing the fast, intense, detailed work needed for each step of that plan. It's a beautiful division of labor. So what happens when you turn that idea into a model? Well, you get this brain-inspired blueprint, which is the foundation for the hierarchical reasoning model, or HRM. It's designed from the ground up to copy that biological split. The HRM is built with 2 parts that work as a team. You have the strategist, or the H module. Think of it as the project manager. It works slowly, it thinks about the grand strategy, the big picture. Then you have the workhorse, or L module. This thing runs fast. It takes orders from the strategist and just powers through the intense, detailed calculations to solve each little piece of the puzzle. But the real magic, the secret sauce, is how these 2 parts work together in a process they call hierarchical convergence. It works like this. The workhorse module goes all in on one subproblem until it finds a solution. Then, the strategist module takes that answer, fits it into the master plan, and, this is the absolute key, it resets the workhorse, giving it a totally clean slate for the next problem. This cycle lets the model do incredibly deep thinking without ever getting confused or stuck. And this unique architecture, it leads to some results that are just unbelievable. We're talking about a true underdog story, where smart design completely demolishes brute force scale. Okay, first, let's just talk about size. The HRM model has only 27 million parameters. That is not a typo. It is a tiny, tiny fraction of the models it's going up against, which makes it unbelievably efficient. And it gets even crazier. It learned to do all of this with only about 1,000 training examples for each task. No massive internet-scale pre-training. This thing is just insanely data efficient. So let's look at the final scoreboard. We already saw HRM just dominate Sudoku and mazes, where the LLMs got nothing. But look at that bottom row, ARC-AGI. This is a benchmark specifically designed to test fluid intelligence and abstract reasoning. And even here, this tiny HR model significantly outperforms the top models from the biggest AI labs in the world. Now, whenever a breakthrough this big comes along, you have to be careful. You have to ask the hard questions. Is this thing really a silver bullet, or are there some catches? And the AI community definitely had some healthy skepticism. And these critiques that came up are pretty fair. Some people asked, is this just a highly specialized AI for logic puzzles, a one-trick pony? Others wondered if this architecture could even scale up to handle messy things like general language. Some pointed out that its ARC-AGI test was done a bit differently than the standard tests, raising questions about whether it's a true apples-to-apples comparison. And it's true, the paper itself doesn't really talk about the model's limitations. These are all good points and a really important debate. But even with all those open questions, the research found something truly profound. It's a finding that goes way beyond the benchmarks and gives us this amazing glimpse into the nature of intelligence itself. Get this. When the researchers looked inside the trained model, they found something they did not program into it. The model had, completely on its own, learned to organize its internal thoughts in a way that looks strikingly similar to the hierarchy of the human brain. They measured this using something called participation ratio, which is basically a way to see how complex the model's internal representations are. And just like in our brains, the high-level strategist module developed these really complex, flexible, high-dimensional representations for abstract planning. At the same time, the low-level workhorse module developed simpler, more specialized representations to just focus on its one job. The model figured this out all by itself. And to be absolutely sure this wasn't some kind of fluke of the design, they checked a brand new, untrained model. Before training, there was no hierarchy at all. This means the model didn't just start out this way. It learned that this separation of thinking was the most effective way to solve these hard reasoning problems. So, at the end of the day, this hierarchical reasoning model presents a powerful challenge to how things are done. It suggests that the path forward for AI might not be just about scaling up the models we already have, but about finding better, smarter, more brain-like blueprints. It really leaves us with a huge question. Is the future of AI just about building bigger models, or is it about finding better ones?